All right, so this is the second set of notes in the packet. So steps to graph a quadratic equation. So now we're going to graph the quadratic equation. If it is in standard form, which is ax squared plus bx plus c equals y or f of x, you can plug this into your calculator. Okay, now let me tell you, y in this situation always needs to equal 0. If there is a number there, you need to get that equal to 0, and we will talk about that more in depth later. But this always needs to equal 0. All right, so you can plug it in your calculator and still get it correct, but when you're doing other math problems, you're going to need to have it equal 0. So in order to graph these, basically, you're going to want to take your calculator, turn it on, and go to graphs, enter, and you really just want to put in your equation. So I'm just going to put in, the y is already in there. Can you see that? Let's see. The y is already there. This is already your y value. So I just have to put in x squared. Make sure you put the square in. And there it is. This is called your parent quadratic function. You're going to need to know this, because this is what we compare everything to. This is what we this is our function that we always come back to, the parent quadratic function. And you'll see that the vertex of the parent quadratic function is at 0, 0. Okay? And since my vertex is at 0, 0, I can tell that from the graph. There are lots of ways you can tell. We can use our axis of symmetry formula, x equals negative b over 2a. In this situation, y equals x squared. My a is going to equal 1. My b, there is no b term, which that must mean that b equals 0. There's no c term, so that must mean that c also equals 0. So when I use this, I'm just going to say, okay, my axis of symmetry, using this formula here, x is going to equal negative 0 over 2 times 1. 0 divided by anything is 0. So my axis of symmetry is going to be basically the y-axis right here for the parent function. Then when I plug in so this is my axis of symmetry. If I were to plug that in, let me see, I feel like this is getting lost, to my original equation, y equals 0 squared. Y is going to equal 0. So my vertex is 0, 0. This is all for the parent quadratic function. All right, so I can put here x equals 0. My vertex is 0, 0. I have both of those graphed. Then I can go to my table. I know where to begin to look at my table because I already know what my vertex is. So I am not going to write these random numbers in my table. That does nobody any good. Please do not do that. Make sure that you are finding your vertex either by the graph or by your formula, and finding your vertex and putting it in the middle of your table so that you've got a couple above and a couple below. Now, I expect there to be 5 points on each graph. 5 points. So I've got my, and one of them needs to be your vertex, and I would suggest the other two be the ones around it. Usually I need your 5 points. So let's write that down. 5 points. I need your vertex, your zeros or solutions, and 2 others. Those are the 5 points that I suggest that you have. And your table as well as on your graph. So going back to the graph, I'm going to put my vertex here, and I would suggest you circle it. Put a V by it so you know that is your vertex. Then I can start looking around. All right, what's happening around my vertex? Well, at -1, y is 1. At -2, y is 4. 1, 2, 3, 1, 2, 3, 4. And at +1, y is 1. And at +2, y is +4. And you're going to notice in all of these graphs that it's symmetrical. So if there's a point over on the left side and it's a whole number, it's going to be symmetrical. All right. So now we've graphed our parabola, which opens up, which we knew because the x is positive. We've got our vertex. We've got our axis of symmetry, which is this line, x equals 0. Now we're looking for the domain. The domain is basically your x values, and it is basically saying, looking at this parabola, what x values will be covered if this parabola were to go on forever? How far to the negative side is it going to go? Well, it's going to go all the way to -infinity. And how far to the right is it going to go? It's going to go all the way to +infinity. So that is including basically all your real numbers. All real numbers. Your range, however, is asking you what of your y values are covered. What is your y value? So to find your range, go to your maximum or your minimum and look on your y-axis. If you go to your maximum or minimum and you look on your y-axis, you know that that cannot go above or below this point depending on what your parabola is facing. In this case, this is my minimum. My y values are not going to be going below 0. So I know that y has to be greater than or equal to 0. Those are the y values covered. All right, hopefully that's going to be helpful.